Home workout. You get home workout. Let's start. You're going to be on page 132 and 133 tonight. And I just realized making these videos that it's completely possible that maybe a couple of you are watching these before we even come back come back to school from break. And if you do, that's fine. I really don't mind when my students try to get a head start on things. But be careful. Because if you don't know what you're doing, you might want to wait until I help you out in class a little bit and we practice together. But if you are understanding everything, well then good for you. Well done. Let's get started right away. Here's a practice problem that they did for you. Becker catches a fish that is 3/12 a yard long. To keep the fish, it has to be longer than 1/3 of a yard. Can Becker keep the fish? Look at how you could show your work using a number line. 1/12, blah, 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 blah. Since 3/12 is less than 1/3, Becker can't keep his fish. Oh darn. Oh, fiddlesticks. But you know what? You don't have to use a number line to get this right. There are other ways. Let's see how we do these problems by ourselves. Myron and Jane are working on the same set of homework problems. Myron has finished 7/9. I'm going to write that down. That's one of our fractions of the problems. And Jane has finished 2/3 of the problems. Who has finished more homework? Show your work. Well, I bet you'd like to just pick which one's bigger. Oh, 7/9 is bigger. Oh, 2/3 is bigger. But you know what? We got to be safe. We have to make sure we know. We can't guess. We have to know. We have to know which one's bigger for certain. How do we do that? Well, one way is by finding a common denominator, making an equivalent fraction. Look at your fractions. Just look at them and start thinking. Is there a way for the bottom numbers to be the same? Can I make 9 and 3 the same? You can. You can make 3 into a 9. You really can. How? How can you make 3 into a 9? Multiplication. 3 times 3 equals 9. Whatever you do on bottom, you must do to the top. You must. You just have to. 3 times 3 is 9. 2 times 3 is 6. Aha! So check it out. Now that we've turned 2/3, we've turned it magically into 6/9 through our multiplication. Now it's very easy to see which one's bigger, isn't it? Because look at 6/9 and look at 7/9. They have the same bottoms. Hip hip hooray. The same denominator. The only thing that's different now is the numerator. A 6 over here, a 7 over there. And which one's bigger? 7/9. Solution. Who has finished more homework? Let's see here. Myron finished more homework because 7/9 is greater than 6/9. La 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 la. That's all. That's all. 1 down, 2 to go. Compare the fraction 3/10 and 7/12. Using a benchmark. Using the benchmark fraction 1/2. So this is how you use a benchmark. Check it out. You should be getting good at this if you practice with me in class. We've got 0. Then we've got 1. And in the middle, because 1/2 is the middle, in the middle, we're also going to put 1/2. Okay, that's step 1. Step 2 is figuring out where 3/10 goes. Now remember, with half, there's lots of different ways to say half. You could say 2 out of 4, 3 out of 6, 4 out of 8. One way to say it is with 5 out of 10. Another way to say it is with 6 out of 12. And that makes sense because when you're saying 1/2, that's the fraction, 1 out of 2, 1/2. Hopefully you see that 5 out of 10, 5 is half of 10. And 6 is half of 12, right? So it makes sense that these are all the same. Now think about it. If this is 5/10, 1/2 is 5/10, where does 3/10 go? Somewhere over here? Somewhere over there? Well, 3 is smaller than 5, right? So it's probably going to go somewhere around here. And now look at 7/12. 7/12 is bigger than 6/12. It's bigger than half, isn't it? So where should 7/12 go? Somewhere over there? It should go somewhere over here. It's bigger than 6, so it should go somewhere over there. Yeah, totally. So now, oh my gosh, all of a sudden, now that we have this number line, our job becomes so much easier. Because think about it, they want to know what's bigger, 3/10, compare the fractions, 3/10 or 7/12. Which one? Well, duh. I mean, 3/10 is over here on the number line, but 7/12 is over here on the number line. So which one's bigger? Which one's further along the number line? 7/12, right? Totally. 7/12 bigger than 3/10. Want to explain that? Sure, we can explain that. 7/12 is bigger than 3/10 because it is further along the number line. Da 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 da. Slam, blam. Thank you, ma'am. We get to move on to the last problem. Pause it if you need to write that down. Pause it if you're not fast enough, okay? All right. Last one. Here we go. Then we're done with homework for the week, at least for math workbook. You might have other homework like science or ELA or whatever. Janelle walked 3/6 of a mile. Okay, thank you. Pedro walked 6/10 of a mile. Alrighty, thank you. Which statement shows how to find the greater fraction? Circle the letter of the correct answer. Okay, so right away I don't like how they put an and here because it looks all jumbled. So what I'm going to do for you to be a nice guy, I'm going to take this red line and I'm just going to draw it through. And it just keep it on two separate sides. So in order for us to pick a letter, each side has to be correct. Okay, so 3/6 equals 6/12. Okay, so does 3/6 equal 6/12? We can figure that out. It looks like they're trying to find an equivalent fraction. So maybe they multiplied the top and the bottom by, what does it look like? It looks like they may have multiplied it by 2. 3 times 2 equals 6. And 6 times 2 equals 12. But you know what? You know why that's not very, that's not very useful? Oh, no. That is useful. Never mind. Never mind. Shut my mouth. That is useful. So 3 times 2 equals 6/12, and 3 times 2 equals 6, 6 times 2 equals 12. Cool. Does anything else do that? 3 over 6 equals... So A could be correct. B has smart stuff. Oh, that has smart stuff. Oh, that has smart stuff. So they all use methods that could be correct. Let's see here. 6/12 is less than 6/10. That does make sense because even though the numerators are the same, the denominator has smaller pieces. This one does not make sense. 3/5 is less than... That one does not make sense. Because the numerators are the same, but you wouldn't pick the one with the bigger denominator. And D, 6/10 is greater than 1/2. 3/6 is less than 1/2? No, 3/6. Okay, so only A makes sense. That's why we looked at it so much before. So this is what they did in A. 3/6 equals 6/12. We just proved a second ago that that's correct. And then they say that 6/12, they say that right here, is less than 6/10. And that goes back to the old rule in fractions that, check it out, I'm going to explain it to you. If the numerators are the same, then that means the greater fraction goes to whatever denominator is smaller. That makes sense because when you're drawing this bad boy, and when you're drawing both of them, if I split this into 12 pieces, which I'm about to do, and if I split this into 10 pieces, which I'm doing right now, and then I colored in 6 of these, and I colored in 6 of these, this shading would look bigger because this has bigger pieces. Because when you're splitting it up into smaller amounts, the pieces are bigger. So this 6 right here is bigger than this 6 right here. Because these pieces, they're split up into bigger pieces. 12ths means more smaller pieces. Tina chose B as the correct answer. How did she get that answer? Well, she started off the same way that we started off, but she thought 6/12 was bigger because she must have thought that a bigger denominator makes a bigger fraction. Hey, if you're confused about everything we're talking about so far, here's the simplest way to put it right here. I'm going to help you out. Tina is wrong because, check it out, because a bigger denominator, and for those of you who can't remember, that's the number on bottom. The number on bottom. Tina is wrong because a bigger denominator, the number on bottom, does not make a bigger fraction when the numerators are, remember what a numerator is? That's the number on top. When the numerators are equal. Tina is wrong because a bigger denominator, the number on bottom, does not make a bigger fraction when the numerators, the numbers on top, are equal. So if you can remember that one fact, that one thing right there that I just wrote, then you're okay. Never mind how confusing this individual problem may or may not have been. Just remember that one fact, and you're going to be A-okay. Alright guys, thanks for doing your homework with me. That's all we got for this week. I'll see you next time. Have a good one. Bye.